Hello YouTube, Ron this side, and in today's video we will be learning about Ingress and Gateway API in Kubernetes cluster. So for the demo I will be using a AWS EKS cluster, but you can use any Kubernetes cluster. It is totally up to you. So let's see what is the agenda of of today's video. So first would be we will be getting an introduction to Ingress. Then we will be learning how Ingress basically works, and then the limitation of Ingress, and then we will be learning a new topic, which is introduction to Gateway API, because Gateway API is implemented in the recent version of Kubernetes, and it has much more capabilities than Ingress. After introduction, we will be learning key feature of Gateway API, then the comparison, like when to use Ingress and when to use Gateway API. And for the demo and example, I will be covering that part after the presentation. So let's get started with this. So introduction to Ingress. So first let's understand what is Ingress. So Kubernetes resources that manages external HTTP or HTTPS access to services. So suppose you have multiple services, but you do not want to use different load balancer or different domain or host, you can say, for each of the microservices. So using Ingress, what you can do, we can create a single point of contact, and we will be just giving the URL part with a service name. I will make it clear when I will be doing the video as well. So Ingress can act as a reverse proxy and a load balancer, because as we have a single point of contact, so it will do the reverse proxy thing and as well as load balancer. And to define Ingress, we have to write some YAML manifest file. So why to use Ingress? So Ingress simplify exposing multiple services under a single IP, which I just explained. Then it also supports TLS termination and name-based virtual hosting and path-based routing as well. So example use case could be routing traffic to different microservices based on the URL path. So how Ingress works basically. So Ingress resource. So these three are the components, like one is Ingress resource, Ingress controller, and service. So Ingress resource is nothing but the YAML manifest file which we will return, where we will be writing the routing rules, and Ingress controller is the one who implement those rules. So Ingress resource, where we will define the rules, and controller is the one who will listen to that rules and apply the same in the cluster. And service are nothing but the Kubernetes service object. So that's the same thing. And this is the workflow. So user requests example.com/API. So API, you can say a URL path based routing, and API, we will be navigating this API to a particular service, and when user use this domain or this URL, then the particular API or particular microservice will be displayed or come into picture. So this is how Ingress work. So first of all, I have not created this image, and I have taken this from internet, and credit goes to the respective owners. So here you can see that we have a cluster, a Kubernetes cluster, in which we have a Ingress and a routing rule, and these are the service which are associated with pods. So suppose a client hits DNS or IP, then our controller would come into picture, and it will navigate the same to the Ingress manifest file or the Ingress resource, this one, first one. Then Ingress will check that what are the rules we have written for the routing purpose, and if the routing rule match to this particular service, then this pod will serve that user. So it's simple. Why? Because if we are not using Ingress, then the user will be directly communicating with service, and then the pod will do their work. But now we have Ingress, then it will do all the stuff, and it will just directly navigate to the user to the particular service. So yeah, we are using Ingress till now also, but there are some still scenarios where we are still seeing some limitations of Ingress. So some of the limitation which we can list it down is that limited to HTTP and HTTPS. So it is basically for level 7 of OSI model, which is for application layer. Because in Ingress we can only support HTTP and HTTPS routing, nothing TCP, UDP or GCP. Then no native support for advanced protocols like gRPC WebSockets, because now the applications, the microservices also support gRPC WebSockets and all. So there we cannot use Ingress. For IoT streams and IoT applications as well, Ingress cannot be very much of useful. Then complex configuration for multi-team environments. So multiple teams cannot work on a single Ingress YAML manifest. So there we cannot use Ingress. And tight coupling between routing and infrastructure. So because as we are just creating a single Ingress YAML, then all the teams have to do their actions on the particular file, and that does not looks good. So these are the limitation of Ingress, which I have listed down and I have observed as well. So now new topic, which is introduction to gateway API. So API gateway is a next generation Kubernetes API for service networking, and it is basically designed to address or to make more Ingress capabilities which current Ingress is not performing. It supports layer 4 and layer 7 routing, which are application and network layer. Level 4 I think is for transport layer. So transport layer as well as application layer routing. And it also supports multi-team workflow and extensibility. Okay, so this is a single or a one-liner definition of gateway API. So these are the key concepts, or what we can say components of gateway API. So one is gateway class. So it defines the type of gateway. So basically we have several type of gateway like Istio, Nginx, K6, K gateway, F5, etc. So here in the gateway class we just have to mention the name, what gateway we are trying to use. Then after defining the gateway class, we have gateway. So gateway represents an instance of traffic management. So you can consider this as a pod or a instance who will act as a Ingress controller, like similarly to Ingress controller, who will be running in front of the service, and it will be the backbone who will be communicating the user with a particular service. After this, we have route, defines how traffic is forwarded. So in here, it is kind of a route or rules. We can say that if we are using a HTTP based service, then we will be using a HTTP route file. If the application is gRPC, then it will be using gRPC route. So yeah, these are the key feature of gateway API. One could be protocol agnostic, because it supports multiple protocols like HTTP, gRPC, WebSocket, etc., which Ingress was not able to support. Then we have role-based access as well. So here what we can do using RBAC, we can separate the concern for infra team as well as application team. So they both can do their work separately, and they cannot like merge their thing into a one file. Then extensible, so custom resource definitions for advanced use case. So yeah, we are also like installing the CRDs for gateway API to work. And another feature is cross namespace routing. which is for enable modular team specific configurations. So yeah, this is the some architecture I can say for gateway API, and this diagram is also not created by me. I have taken this from internet, and credit goes to the respective person or the team. So let us try to understand how is the architecture of gateway API basically. So here you can see the one component which is gateway class, where we mention which gateway we want to implement or integrate. So it is done by the platform team. So the platform team will be the responsible for doing the stuff for gateway class. Then gateway come into the picture, which is handled by the DevOps team. And in the gateway, we will be mentioning the rules, the routes and all. And the DevOps team will be the one who will be responsible for this. And apart from gateway, then we have the routes. What could be HTTP route, GCP route, etc., where application developer can define their routes, their rules, and that could be handled by them, and which will be redirecting the stuff to the service. So yeah, that was the architecture, a simple architecture I would say, how the how different team would be working for gateway API, and who will be responsible for what. Then we have this difference, what we can consider if for some use case where we want to use Ingress and where we want to use gateway API. So if you are just supporting HTTP and HTTPS protocol, then Ingress would be a better option, because it's not that much complex. And if your application is small, or it is not having a multiple team, then Ingress could be one. But if you are having, or if you want to support multiple protocols apart from HTTP and HTTPS, then gateway API is the one. Role separation, in the role separation, Ingress is limited, but for gateway API we have gateway class. Then for extensibility, extensibility is very minimal in Ingress, but for gateway API it's high. Custom resources we can perform, and if we have multi-team workflows, then doing that using Ingress is challenging, or it's a little bit complex. But for gateway API, it is a native support, so it won't be a very much issue if you have a multiple team within your project. So yeah, that was all for the theory part, I would say, about Ingress and gateway API. So now let me start with the demo part. First of all, I would like to display that or show that this is the demo repository I will be follow throughout the video. I have created a 3-tier application, or simply a MERN application. For front end I'm using React.js, and for back end I'm using Node.js, and for the database I'm using MongoDB. Application is not built by me. I've taken all the help from LLMs and all the AI. So you can see the code, and yeah, one more point, I will be using this demo branch. So if you want to play along after the video, so please make sure that use demo branch. In the backend, everything, all the code is for the backend part. It has its own Docker file, and same goes for the front end. Because I have not created the application by myself, so I am not a better person to explain the code. But yeah, if you have a basic understanding of how development works, then I think you can easily understand what the code is. It's just a basic to-do application. So yeah, in the kits folder I have a backend YAML, where I'm just creating a deployment as well as a service for my backend application, where I am also passing some environment variable for the Mongo part. And for that I'm using a config map. It's a simple, nothing complex, because the main intention of the video is for helping to understand how Ingress and Gateway API works, not how the application works. Same goes for the front end. For front end, I'm not passing any environment variable, so yeah, I'm just using a deployment and a service. Then comes the MongoDB thing. So for MongoDB, I'm using their image, which is Mongo latest, and here I'm just passing the environment variable, which is for the database name, and this is the service, and it is a stateful set, because we need to store, or we have the priority of the state for MongoDB. Then comes the Ingress part. So in the Ingress, this is the single YAML manifest file which we have to maintain across the video, where we will be learning about how Ingress works. So here this is the API version, kind is Ingress. This is the name I have given, and I'm installing this or using Ingress in my default namespace. So this is the thing which we have to consider. So I'm using NGINX Ingress Controller. So that's why I have used Ingress class as NGINX here. You can use any, maybe you can use F5 ALB Ingress Controller, anything, but this annotation would be then different. After this, in the specification, Ingress class name I have given NGINX, and in the rules, this is the main part. If you will check here in the component parts, yeah, so rules. So here implements the rules. So here in the ingress.yaml, we have created the rules, and those rules will be taken care by the Ingress controller, which will be installing just after some time. And in the rules, here we are passing that the rule is for HTTP base, and these are the path it has to follow. So here we are giving two paths. One is slash and another is slash API. So slash is using front-end service. So this name is coming from here. If we go to the frontend.yaml, and in the service snippet, here you can see this is the front-end name. So this is how we are using that name, and same goes for the backend. And I am exposing both the services on port 80, which you can see here. So this is the port for my backend application, but the actual application or the pod will be using this 5000 port, which is the default port. And for the front end also, both of them are using 80. Okay, so this thing is done. And yeah, so here in the host, I'm using a load balancer IP, because I'm using a AWS EKS cluster, and as we are using a cloud-based EKS cluster, then we can use this. So this is different. This is the one which I was working as a POC. But yeah, when we will be installing Ingress controller and all, then we will be updating this IP address. Okay, so I think we are good. And yeah, so I have already cloned the repository in my cluster, and I am using a EKS cluster with 5 worker nodes. Okay, so I think we are good, and we can start with the video. So now let's go to the KX folder, and yeah, let's first try to deploy the application itself before doing the Ingress stuff. Okay, so kubectl apply -app. So this app folder has all the deployment and service for my front end as well as back end as well as my database, and everything is getting deployed or applied in my default namespace. So let us check if the pods are running or not. Okay, so backend pod, frontend, and MongoDB is up. We have 3 replica of MongoDB, so we have to wait for it to be ready and running. Meanwhile, what we can do, we can check the logs of frontend and backend. So for that, we can use kubectl logs, then the name of the pod. Okay, so my backend pod is running, and it is showing that it is running on 5000 and it is connected to MongoDB. This is good. Then let us check the logs for my front end as well. Okay, so this is the one. Cool. So I think front end is also up and running. Let me check if my all the replica of MongoDB is up and running or not. Okay, so MongoDB 0.1.2 is running. Okay, so I think we are good. kubectl get service. Okay, so all my application is using cluster IP. So now the main thing comes into picture. Now we have to install Ingress Controller. So for Ingress Controller, I will be using NGINX, I think, which I have already told the same when I start the video. So yeah, to add Ingress Controller to our cluster, we just have to run these 2 Helm commands. Yeah, one prerequisite you can also note that Helm is important. If you do not want to use Helm, you can directly apply the YAML manifest file also. But yeah, I have already mentioned the commands in the readme. Then I would suggest you can go with Helm. Okay, so Helm repo is already there. Okay, it's good. Then I think Helm install will also be not required, but let me run this command. Okay, okay, I think repo was added, but it was not installed by me. Okay, let's wait for it. Okay, so it is done, and what we can do is we can check if it is working or not. So kubectl get pods, and it will show me Ingress as well. Okay, so yeah, here you can see Ingress NGINX Controller is also working, and I think it will take some time for get to be ready. Let me run it again. Okay, so it is also running. Cool. Okay, yeah, so I think it is good. Now let me check the service for this. Okay, so Ingress NGINX Controller is the one which I have already explained here as well. So Ingress Controller is the one because it will implements the rule, and it will run as an instance, and it will the one who will be using or communicating directly with user, and it will redirect the traffic to the particular service. Okay, so this is the external IP we have received from AWS. So what we have to do is now we have to go to the Ingress folder. Then I have created this Mun Ingress, nano Mun Ingress. Okay, so this is the YAML manifest file I have already explained you. So now what we have to do is we don't have to do anything. We just need to change the host here, because this IP I have used earlier and it's now deleted, so it's of no use to us. Yeah, so I have pasted the new host, and let me save it and exit from this. Now what we have to do is we just have to apply this YAML manifest file. So for that, kubectl apply -f, then I think ingress, then Mun Ingress file. Cool. So our file is created, or we can say our ingress is created. So to check ingress, so what we have to do is we have to write kubectl get ing or ingress. So now what we have to do is we just have to use this host, and we have to come to our browser, because now the application is exposed to outside of the world or outside of the cluster. Then we can access this. So see, our front end is working correctly. I can see that. Now let me add a to do here, so that we can also check if backend and my MongoDB part is also working or not. So here what we can write is implemented, let us write installed Ingress controller in AWS EKS cluster. Now let me just hit add here, and boom, so we can see the entries made, and we are also seeing some option of completing and deleting it. It is of it's of no use to us, basically, because it's a development thing. Now let us check the backend part as well. So for that we just have to write /API/todos. So if you remember, /API is the one which we have written here in the rules, that whenever the path is /API, then it will be going to the backend service, or it will trigger the backend service. Then that will display our result. And /todo is the one because in the code, if I go here in the front end, src, yeah, so here the base URL which I am passing is /API/todos, which is directly associating with the backend. If you know this development stuff better than me, you will understand it very easily. But yeah, for newbies or for the person who is not very much familiar with development stuff, so this is how I am writing that API endpoint, and now it will show us the backend part as well. So here you can see the entry which I created in my front end. It is also getting displayed here, that installed Ingress controller in AWS EKS cluster. This is the ID, and this is all the stuff which is like handled by the MongoDB stuff. Okay, so what we can do is let me complete this. So after we do the complete part here, it will give a strike through here, that now it is this part, or that this to do is completed. Now when we will refresh here, then instead of completed, which earlier it was showing false, then it is showing true. So we can say that my front end and back end both are in sync, and my database is also able to store that. If I do the refresh here, then I can see the created to do easily. So I think I'm able to explain how the Ingress works. So from Ingress manifest file also, you can also consider, or you can see that whenever we have to do any operation, then we have to open the main Ingress YAML, and here we have to add the host rules, and even we have to modify the host as well. So this is how I did it. But now this is the limitation which multiple teams or multiple members were facing when Gateway API was not developed or released. So now let us understand how Gateway API is working. So yeah, so one more thing. So for Gateway API also, I'm using NGINX Gateway Fabric. So it is also a gateway class which I am using in the demo as well. So for Gateway API, we have created a gateway YAML and one HTTP route YAML. So let us understand what is gateway YAML here. So this gateway YAML is here we are mentioning the API group and the version. In the kind we are giving the gateway, and in the name we are giving this as a gateway, and for this I'm using a specific namespace, because I think that I should not merge or mess everything into a single namespace, so that's why I'm using this. And in the gateway class name, in like earlier we were using this thing, right? Ingress class name. So instead of Ingress class name, here we are using gateway class name. So here also we are passing NGINX because I'm using NGINX as well. And here in the listeners, we have given that we have one listener, like because my application is a simple and it is working on HTTP protocol. So this is the listener name I'm giving. The port it is working is 80 and the protocol is HTTP. And here we are passing allowed routes, and in the routes we are passing the rules for which route can bind to the particular listener. So this is the listener name, and in the namespaces we are giving from all. So we are allowing routes from any namespace which is running inside my cluster. So this is the gateway YAML where we are just passing the routes and rules. And now HTTP route or HTTP route to be specific. So here we have created a separate YAML manifest file, which was not in the case of Ingress because we have merged everything into a single file. But now as gateway APIs for multi-team workflow, so here we have separated them, and particular team or the member is responsible for doing their work. So here here also we are using HTTP route in the kind, and we are giving this HTTP route as front-end React routes. So because this is for my front-end part, and in the spec for referring for parent reference, we are giving which gateway and listener is this have to be attached. So here I'm passing the name as gateway because this is the name of the gateway I've provided here. Then the namespace gateway API -nginx because this is a specific namespace I'm using my gateway to be installed. Then the section name is HTTP. So HTTP is the listener name from gateway spec. So here you can see in the listener, in the name we have HTTP. So this is the name we are passing there. Then in the host names, the same like how we did for the Ingress, then the same we are doing for here. And in the rules, the same concept you can say that what we have used in Ingress, the same thing we are doing here as well. The same thing I have done for backend as well, HTTP route, and it is also referring to the same parent, which is gateway, using the particular namespace. Then HTTP section name, this is the host names, and yeah, this is the value of my path prefix because it's basically based on the path based routing. So /API is required, and this is the service name, and this is the port which it listen. So yeah, we can say that this is kind of a brief how we will be implementing gateway API here. Cool. So let us go back to the README again because now we have to set up and implement gateway API. So for that also we can use Helm, and I'm using this kubectl customize command because it was mentioned in the official document as well. So we can use this as well. So now what we have to do is we have to go again to our cluster, throw the command and apply it. Now it will install all the CRDs and all for my gateway API. So here you can see that it has created 5 CRDs, and each of them is working separately. How separately is because one CRD is responsible for creating the gateway classes, another is for gateway, one is for GCP routes, one is for HTTP routes, and one is for reference grants. Okay, I have also given a one-liner to each of the CRD. Okay, so what we can do, we can verify the same here as well using kubectl API resources that how many gateways are installed or not. So here you can see gateways, like almost everything which is related to gateway here. Okay, cool. Then yeah, so now what we have done is we have installed the gateway API CRDs, but now we have to install the controller, because controller is the one who will be doing the work which CRD has to do. So let me clear this and paste this and hit enter here. Okay, so it is deployed, and it is deployed in my gateway API Nginx namespace. So let me check kubectl get svc -n, like what all services is running inside this namespace. Okay, so okay, my gateway fabric is installed. Okay, cool. So now what we can do is we don't need to like do everything like whatever written inside this. Okay, now deploy the application. So what we can do is our application is already installed, like what it is already running. What I can do is now I can directly apply my gateway API stuff. So what I can do is, let me first create the gateway. Why? Because as soon as I will apply my gateway, then I will get a hostname, because hostname is the one who will be responsible for running the instance in my cluster, and who will be the one who will be bridging the gap in the communication for my outside world user with my services. So what I can do is kubectl apply -f, then it is inside my gateway, and let me just first apply my gateway. Cool. Okay, so my gateway is created. Now let me check the pods for this as well, specifically in this namespace. Okay, so my gateway is running, and my gateway fabric or my gateway class is also running. Now let me check the service as well. Cool. So my gateway is exposed to outside world, and it is using an external IP. Okay, so now this is the external IP which we have to use for our HTTP route, what we have written inside that. So let me open that file. It is inside gateway API, then man HTTP routes. Cool. So these are the HTTP route what I have already explained. So what now we have to do is we just have to modify this DNS name from my front end as well as back end. So now it is a one thing activity I'm doing. So whenever any DNS name is changed, so every time we just have to open this HTTP route thing, and we have to modify the properties. So now we don't have to touch or interfere for gateway file which we have already applied previously from this file. So now let us save and get exit from this file, and let us apply this file as well. kubectl apply -f, then the same path here. Cool. So our front end React route is also created, and backend node route is also created. So now what we can do is kubectl get gateway. Do we have such thing? Okay, in the default namespace we don't have that. I forgot here. So this is the one gateway which is of class NGINX, and this is the address. So this is the address what we will be using to access the application. So here please note that this is the endpoint for our ingress, and what I'm now try to access is for gateway. Cool. So now this DNS is also working correctly, and my gateway API is also working correctly. Implemented gateway API in AWS EKS cluster. I have added this. Now the same thing, we can also check the backend service related to my HTTP route, which I have used using gateway. So for that also the same endpoint we have to use, API to do's, and here you can see that it is giving me the entry which we have just now added, which is implemented gateway API in AWS EKS cluster. As it is a to-do for us, but now we have successfully integrated and installed it, so we can mark this as complete. And yeah, let me just refresh this and see, both of them are true. So please don't get confused that it is showing me the previous as well, because the application is same. Application is using Ingress as well as gateway API, so that's why the entries are same. What you can do is you can like try to implement different application or different deployments for each of them, and you will get to know more about that. So this is all for Ingress controllers and as well as gateway API. So I hope I was able to explain you how both of them works and when we need what. So thank you for your time and have a nice day.